All right, welcome to This Explainer. Today we're unpacking a really fascinating chapter called Water, the Essence of Life. And we're going to take this amazing zoom in journey, starting from the vastness of the entire planet Earth and going all the way down to, well, a single little insect in a pond. So let's jump right in. Whenever we picture our blue planet, it feels like water is just infinite, right? But to put Earth's freshwater scarcity into perspective, the text gives us this really striking ratio. Imagine a standard 200 milliliter glass holding all the water on Earth. Out of that entire glass, the amount of usable freshwater would be a measly 5 milliliters.
Okay, let's dive into this because the textbook uses a powerful analogy to make that math even more visceral. 5 milliliters? That is exactly 1 teaspoon, literally. Out of a whole glass representing the planet's entire supply, we get a single teaspoon of fresh water. It perfectly visualizes just how much heavy lifting this tiny fraction of a resource does to sustain literally all terrestrial life. Which brings us to a really curious question from our source text. Is there water in the air too? I mean, we've talked about the liquid water on the ground, that precious teaspoon, but we kind of have to pivot our narrative to the atmosphere now. How does it move around? Does it just sit there in lakes and rivers? To figure out how this shared resource reaches everywhere, we actually have to look up. To prove this, the chapter outlines a super clever DIY visualization of the water cycle. You literally just draw a sun and some clouds on a transparent bag, fill it about a third of the way with colored water, seal it up tight, and leave it in the sun. What happens? You get condensation. It's a localized microclimate right on your windowsill that physically proves how solar heat lifts water into the air as vapor. It's a really tangible reminder of this massive global mechanism.
And when that rain eventually falls back down and replenishes our freshwater habitats, it sustains environments that demand some radical biological divergences. The text provides a pretty fundamental contrast here. Terrestrial animals, animals on land, use legs to deal with gravity and obviously can't breathe underwater. But animals in these rare freshwater ecosystems, they have entirely different evolutionary solutions. We're talking fins for swimming and incredibly specialized mechanisms just to extract oxygen underwater. Now, what's really interesting here is how wildly varied these survival strategies are, even within the exact same water source. Take the pond heron, for example. It relies on absolute stillness, using those long, stilt-like legs to just wait for a catch. But then, look at the soft-shelled freshwater turtle. It takes a completely different approach, actively using its highly adapted limbs as fins to paddle around and navigate the depths. And honestly, the adaptations get even more specialized. Have you ever seen a water scorpion? It hunts underwater using these intense pincers, but the crazy part is how it breathes. It uses a literal built-in snorkel. Yeah, it has this specialized tail tube that it pokes just above the surface to get air. It's an incredible, highly specific microadaptation just to survive in that precious teaspoon of Earth's water. Then, of course, we have the dragonfly. Now, while the water scorpion is diving deep, the dragonfly is zipping through the air right above it. It flies unbelievably fast and relies heavily on this very specific habitat because it has to lay its eggs near the water. But more than just breeding there, it plays an absolutely crucial role in the ecosystem by eating mosquitoes. It's simple. Lose the pond, you lose the dragonfly, and suddenly, bam, you're dealing with a massive mosquito problem. And this brilliantly illustrates the big picture. Zooming out from the heron's legs and the scorpion's snorkel, we see the complete, vibrant ecosystem. The chapter aptly calls this our wondrous freshwater habitat. And there's a food chain exercise in the text that highlights a pretty harsh reality. If you remove just one of these creatures, the entire interconnected string collapses. It's like a giant puzzle, really underscoring how incredibly essential this shared habitat is. But, we really have to bring the science into our own neighborhoods because human activity directly impacts this fragile system. The text points out a huge modern problem: the way we build our cities. Concrete roads, paved areas, cemented surfaces, they basically act like a giant shield. When it rains, that water just cannot go into the ground easily, which totally stops our groundwater from getting recharged. Compare that to open, green lawns or forests. Those open spaces act like sponges, allowing rainwater to naturally seep back into the earth to refill those hidden underground reserves. So the crucial point is, we actually have the power to fix this imbalance. The source outlines several highly actionable solutions for groundwater recharge. By actively building things like soak pits, ponds, and human-made lakes, we're providing dedicated places for rainwater to collect and seep downward. And planting more trees? Absolutely crucial. Their root systems actively help guide water deep into the soil.
we can literally help the rainwater return underground.
So I want to leave you with a direct, really provocative challenge straight from the source text. Think about everything we've covered today, from the absolute scarcity of that 1 teaspoon of fresh water, to the interconnected bugs and birds, to the modern problem of our paved cities. With all of that in mind, can you design a house or a school that conserves water wisely? What specific features would it include to ensure rainwater actually recharges the ground instead of just running off a concrete slab? Think about it. See how you can step up and become an active participant in protecting the wondrous essence of life. Thanks so much for learning with me today.